Hey, this is Mike with RPS Water Pumps. Today, behind me, I have the EcoSteady 3 horsepower booster pump. Let's go check it out. So right here we have our 3 horsepower EcoSteady booster pump, and that's a constant pressure booster pump. That's made to take water that's either at low pressure or at no pressure, like in a storage tank, and then it pressurizes. But the great thing about this pump is it's constant pressure. So what that means is there's a pressure transducer here that senses the output pressure of the pump. And so if there's no water being used, the pump shuts down into a low power mode. But once it senses water is being used, it can sense the exact amount of water being used and adjust the motor speed to maintain our desired pressure. So that means there's no pressure switches, there's no added pressure tanks. All you have to do is supply it water and then it's going to pressurize it. These are super popular with households, also for livestock, irrigation, whether you're doing a smaller farm, wherever you need pressurized water, this is going to be able to pressurize it at a constant pressure without a bunch of extra equipment. So let's talk about the specs of this pump. At household pressures in the 50 to 60 PSI range, it's going to produce 30 gallons a minute, which is perfect for a majority of houses. If you're doing drip irrigation, it's going to be slightly higher. We're going to produce around 50 gallons per minute because we'll be running at, say, 30 PSI for either drip or sprinklers. And that's perfect for long runs or multiple branches out in your garden. Let's check out what that looks like when we turn on the pump and we let it free flow out. And so you can see that's quite a bit water. This is open flow, so we're looking at more like 60 gallons a minute, maybe 70 gallons a minute out of this 1.5-inch water line. The great thing about this pump is, like I mentioned earlier, it's constant pressure. So as we restrict this back, speed of the motor is going to adjust in order to maintain our output pressure. And when we get this fully shut, now the pump can sense that we're no longer drawing water, and so it's going to sit here for a couple of seconds and then it's going to go to a low power shutdown mode because it knows no water is being drawn out, and it's just going to sit there and wait until more water is being drawn and then turn back on. And so you can see no more water is being drawn, and so the pump's gone back down into the low power mode, and it's sitting there waiting, and as soon as we open this back up again, the pump ramps right back up and continues to maintain that constant pressure output. So let's talk about the various components we have here with our complete system. And so here we have our BP3 EcoSteady booster pump. On the top here is our controller. This hooks into our pressure transducer in the back, which maintains that constant pressure output. Down below here we have our permanent magnet motor, and so that's going to be the most efficient type of motor on the market because it does use those permanent magnets, and so that's going to draw less power per gallon pumped out of this system. Up here is our pump end, and this contains our impellers inside, and then this is going to go up into our check valve assembly here. So the check valve assembly, there's a built-in check valve, and so that's going to maintain our pressure. So that means we don't have to add on an external check valve on our outlet because that's all built in here. The pressure transducer goes on the back side here. And then we have both our inlet and our outlet. They're both 1.5 inches, and our inlet is coming in here. And so this is coming from our water supply. And our water supply could be from a tank. It's really nice if we have slightly elevated pressure. Positive pressure going in here because it's going to help us purge the system of air and get it primed really easily, but it can also do a reasonable amount of suction. If we're doing 5 to 10 feet of suction, it can suck it out of a tank, out of a pond, wherever that water source is if it's down below. And so that's the 1.5 inch inlet here. It goes through our impeller stacks, out our check valve here, and then out into our 1.5 inch outlet over to whatever plumbing we're running. So if you have 1.5 inch plumbing, great, it'll come back in here. That can also go to larger plumbing, say if you want to go to 2 inch or larger, or it could also be neck down at this point if we want to go to 1 inch or 3/4 inch if that's the inlet into your house, cabin, or wherever else you're using the water. There is a small expansion tank here, and so this just helps stabilize the pressure and keep everything running smoothly. But the great thing about this is we don't require a big, large external pressure tank like your normal pressurized system. Like say you're using your well to bring the pressure up, you have to go from your well up to a pressure switch, and then you also also had to put in some bladder tanks or expansion tanks. With this constant pressure pump, none of that's required. It's an all-in-one system here. And then here in our outlet, we went 1.5 inches, and in this case, we went to some various hoses. I'm gonna show you how it works with our sprinkler system. A lot of the times we would put a main line in here and then draw off our sprinklers from that main line. But instead here, to keep it very portable, we instead did a bunch of hose bibs and then hose going out to our various sprinkler. So as you can see right now, we're in a low power shutdown mode. The pump's just sitting here and the system is pressurized. So there's pressurized water in these lines, but since there's no water flowing, the pump can sense that and it stays off in that low power mode, waiting for any water demand, and then it's gonna fire up that motor to maintain that constant pressure. So over in the distance, we can start turning on our sprinklers here and we'll hear this motor start to ramp up as we turn them on. So you can see we turn on our first sprinkler, it's over here in the system, and we heard that motor spin up. Now it's still running really slow because there's not much of a demand. There may be like 3 to 5 gallons per minute for one of those sprinklers. But as we continue to turn on sprinklers, this pump is going to maintain that constant pressure by speeding up the motor and producing more water to match the exact demand back behind me. So our next sprinkler over here turning on. And so you can see we turned on all our sprinklers here. They're all running back behind us. There's so much pressure, one even fell over back there. The great thing about this system is we can tailor it to the exact amount of pressure we want. And so at this point, we're running pretty high here. But if I wanted to turn it down, it's as simple as pushing a couple of buttons here in order to reduce the pressure. And you can hear that the motor is slowing down in order to match the pressure I'm setting here on our display. And so a lot of times for sprinklers like these, we will want in the 50 to 60 PSI range. But if we're running, say, drip line, those a lot of times run at 30 PSI. So it's as simple as dialing this back to the exact pressure we want for application. So as you can see, as I'm turning this down, the sprinklers are all going down back behind me. So let's take a look at our keypad here. And so right now we're running at pressure 5, and that's in kilograms per centimeter squared. And so in order to get that to PSI, we need to multiply it by 14.5. So 5 times 14, running a little bit over 70 PSI, which is pretty high just for this demonstration. In a normal household, we probably have this set anywhere from 50 to 60 PSI. So when this controller sits for a little bit, after you've changed any of the settings, it goes into this lock mode here, shown by this little lock. And so to get out of that mode, we want to push the plus and minus button, and now the lock goes away. That allows us to change any of the settings here. And it also prevents, when it is in lock mode, from somebody coming along and changing your settings and messing anything up. Now it's super easy to program here, and there's basically no programming out of the box most of the time. With this boost mode, it's going to be plug and play. So you're going to hook up your water source, you're going to hook up your power source, which is going to be single phase 220 volts, and then this is just going to run. A majority of the time you won't have to change any of these other settings. But like I showed earlier, we can adjust our pressure here, and so this is going to be our set pressure. And so instead of 5, we could go down to, say, 2.5, which is going to be right around that 30 PSI range. And so this is great for drip irrigation, lower pressure systems. But for household, we're going to be a little bit higher here. We're going to be up in 4.5 to 5. Great, so we'll stop here right at 5. It's going to be flashing, that's our set pressure. And then in a couple of seconds here, it's going to switch over to our actual pressure, and that's the pressure that the system's at currently. The standard mode we have here is called boost mode, and that's taking and doing the constant pressure watering. Another mode I really like is the time mode. And so in this case, we can set a timer for whether it's half an hour, 3 hours, or 12 hours. And this is great for irrigation where we're running sprinklers or drip irrigation or anything else. We can set a timer for 3 hours, the system's gonna run, and then after that 3 hours, it's gonna shut down once it's completed the watering. We'll go back to our standard boost mode. This is the most common for household, a lot of the irrigation where you're using timers or other valves to turn off and on the water. When we turn on the pump here, and I'll get it fired up real quick, we're gonna see the display starts to turn on, and we're gonna get our run light. So the run light turns on anytime this pump is on, and then it's gonna display our output pressure. Right here, we're hitting right around our 5.0. We can also toggle what's being displayed. The M is feet in pumping meters. This isn't very common. If you're curious, you can find out the RPM the motor's running at. Currently we're running at 3,800 RPM. And then this one's great. This is the amount of power we're using. So right now this pump is using around 1.27 kilowatts of power. And as we increase our water demand, that kilowatts is going to increase. So as we're turning on more sprinklers here, the pump is going to speed up and consume a little bit more power. Here we're now consuming with 1, 2, 3, 4 sprinklers on, we're at 1.7 kilowatts. You see demand greatly dropped. We went down less than 1 kilowatt, and then we're going to our low power shutdown mode, and it's basically drawing zero power. It's just monitoring the pressure here. The motor's not running, and it's just waiting till it senses water's being used in order to start back up. There's one other mode we have here, which is called override mode. And so it's not very common, but occasionally we do have issue with our pressure transducer. These are super easy to replace. They unscrew, they screw back in. Not very common that we ever have any problems with that, but if you ever have any problems with the system and you need to get water, you can turn on the override. That's gonna move on our emergency light, and then that's gonna force the pump to turn on and disregard our pressure reading. This is good for short term. If you need to run for a couple of hours in order to take a shower or something else while we're getting replacement parts. But again, that's not very common at all. We don't expect that to happen, but we did include the setting just in case you ever need it. So we're back in our standard mode here, and that's basically it. There's one more light that's called multi-P light. And so the great thing about this pump is if you want to run additional pumps in parallel, that's no problem. So like I said, this is gonna run anywhere from 30 to 50 gallons per minute. Or less depending on your exact water usage. But if you need to produce more, we can double that. So we can put 2 pumps together here side by side. We can put them in multi-pump mode, and then they're gonna synchronize in order to double our output water. And we can basically keep adding on as much water as you need. You can keep adding pumps on. And they're gonna turn on in series. So if there's a little bit of water demand, the first pump's gonna turn on. As that water demand increases, the next pump's gonna turn on, and the next pump's gonna turn on. So basically, by adding pumps in parallel, we have a limitless amount of water that we can produce. So we've seen how this pump's operating. Let's get a little bit more into our exact plumbing here. And so in this case, we're using IBC storage tank. You can use the black poly tanks, whatever tank you're using for your water supply, you can use that. So whatever tank you have, this pump's gonna work with it. One of the great things about these tanks is when we have the outlet on the bottom, we're gonna maintain some sort of positive pressure, which really helps with priming this system. And so here we have our pipe running over to our pump in our inlet on the front here. To make things easier on us while we're setting it up and in the future, we've included some various valves both on our inlet and our outlet. So if we need to do any plumbing work here, we can shut off our tank valve, do the plumbing work, and not worry about all the water from our tank running out. And we also included a union here. In general, I usually include a union up over here. That just makes any disassembly much easier. We can unscrew the unions, we can remove the pump, just makes everything much more modular with a plumbing system like this, where we're using a majority of glued fittings, having those unions in. In this case over here, we did add a pressure gauge. Now this is optional, it doesn't come with the pump, but there is a port in case you do want to add a pressure gauge. This is nice just so we can see the exact pressure in our outlet. Takes out some of the guesswork on what exact pressure we're running, but majority of the time we can just set it with the screen, and this is a set and forget pump. Set the pressure on there, and then it's just going to maintain that exact pressure. We don't have to fiddle with things in the future. So another great feature of this system is our run dry protection. So if we ever draw down this tank too far, or we get any air in the lines, we get a clog here, say somebody forgets and turns our valve off, this pump has run dry protection. So it's gonna sense when there's not water flowing, and yet there's a demand for water and the motor's running. And so it's gonna allow that for a couple of seconds, and then it's gonna shut down the pump to protect it from running dry and overheating or any other damage that can occur from that. So this pump system, it varies from a standard booster pump in a couple of different ways. And so a standard booster pump's also going to run an AC power, but it's going to require that accessory hardware I talked about. It's going to need the pressure switch. It's going to also need the bladder or pressure tank in order to stabilize that pressure. And then when the system's running, that standard type of pressure pump, it's going to constantly cycle and turn on and off every time there's water demand. And so once that water drops in our pressure tank, it's going to fire up at full speed, then it's going to fill up that pressure tank, and then it's going to shut off. So that can cause what's called short cycling of the pump if we don't have that system designed exactly. Say our pressure tank's a little small, they also can get waterlogged over time, and that causes a lot of issues. With this system, it's got that built-in controller, and so it's just going to sense if we're using water, and this could simulate, say you're doing dishes inside your household, and you're using water off and on, and then as we use a little bit here, we're going to hear this motor start to ramp up, And it's just basically, as we're going, adjusting the speed of the motor to the exact amount of water usage. And so this is gonna be great if you're in a household, people are running a couple of showers at the same time, say somebody's doing dishes. The pump's gonna sense all that, and it's gonna provide the exact amount of water to maintain that pressure that they're using. And you can see here, somebody's doing dishes inside, and then somebody out back decides to turn on some sprinklers. It's no big deal. We're still maintaining our water pressure inside our house while we're out back also irrigating or doing other gardening needs. And so like I mentioned earlier, this pump is a permanent magnet brushless motor. And so that provides two things. One is the permanent magnets are more energy efficient inside that motor. So normal induction motor that's running on AC, we have to induce a current in those windings, and that results in extra heat and extra power loss. And so that means for every gallon pumped, we're gonna have to provide it more watts, which is also a higher electric bill. With this motor and with this controller, it's much more energy efficient because we have those permanent magnets and it's also brushless. And so unlike a normal DC motor, there's no brushes to wear out over time. So this is gonna last years and years. But like I mentioned about a standard AC booster pump, every time that pump is cycling, there's what's called a surge current. And so that can go anywhere from 30 to 50 amps, and there's that surge current going through the windings, and there's also a jerking starting motion of that. So that's gonna cause, over time, wear and tear on the motor. It can also cause wear and tear on our plumbing components as that motor jerks and it starts up. Here we have soft start, so everything is super smooth. And so every time this pump is starting and shutting down, you can hear it's ramping up and down. And so there is no surge current, there is no surge torque there that causes that stress on our components. And so that means it's gonna be a lot longer lasting. It's gonna work years and years in the future because we don't have to worry about our motor burning up, we don't have to worry about stress in our components, and also most important, with our bladder tanks and other tanks, we don't have to worry about them getting waterlogged or failing over time. So that's the basics of our BP3 EcoSteady booster pump. It's a super versatile pump, whether you're using it to pressurize water for your house, your livestock, your sprinklers, your irrigation, it's gonna do the job for you. It's super energy efficient and it's packed full of a ton of features like our low water detection and constant pressure. So if you have a water pressurizing system need, give us a call or visit us at rpswaterpumps.com to get your pump today.